All right, welcome. In this video, we are going to be proving and just examining the midpoint theorem as well as the angle bisector theorem. So to start off, let's just take a look at what is the midpoint theorem exactly. So the midpoint theorem states that if M is the midpoint of segment AB, then AM equals half of AB and MB equals 1/2 of AB. So basically what we can see here is that it's just saying, all right, if M is our midpoint, then each half makes up half of the whole. So each part that midpoint divides the segment up into is going to be exactly half. And that makes sense, right? If we're going to add up two equal parts, they each have to be half of the whole thing. But we want to use this as a proof. Let's state exactly what we are doing. All right, so let's state how we were able to come up with that. And we were able to just sort of talk through it. Now it's just a matter of let's get it down on the paper, okay? So we have our statements in the left column, our reasons in the right. Remember that we're always going to start with our given information first. So we are given that M is the midpoint. Okay, I'm just going to write M dot P for midpoint. Otherwise, I'll be running out of room because I don't have a ton of room on this screen. So M is the midpoint of segment AB, and remember our reason for that is just that it's given. Well, what do we know? What do we know? What does the midpoint tell us? Well, the definition of a midpoint actually tells us that it splits up a segment into two equal parts. So it tells us that AM is going to be equal to MB. So it's splitting it up into two equal parts. All right, and that is our definition of a midpoint. Definition of midpoint. All right, and we'll examine the difference between the midpoint theorem and definition of a midpoint on the next slide. But the midpoint, again, definition of a midpoint just tells us that it splits it up into two equal parts. All right, our next step now. All right, well, where can we go from here? Let's take a look at our picture and see what we have. Well, what can I say about AM, MB, and AB? What is their relationship? Well, I know that AM and MB together have to add up to equal AB. AM plus MB, right? Each of those two parts added up must equal the whole. All right, that has to be true. And why is that? We think back to chapter 1, and that's when we learned this segment addition postulate. So our reason for that is segment addition. All right, our next step now. Well, I'm trying to get it to say AM equals 1/2 AB and that MB equals 1/2 AB. Well, what I could do here is I know AM is equal to MB, so I could just substitute one in for the other, right? If I substitute in and say, all right, well, in this case, AM plus, and then I'll substitute AM in for MB, right? I know AM equals MB, so I'll just substitute in for this MB. I'm going to say, well, instead I'm going to say AM plus AM has to equal AB. All right, and that's the same exact thing as 2 times AM. 2 times AM has to equal AB. And what did I do there? I substituted. So substitute will be my reason. All right, substitution. All right, in my next step now, let's just divide that over. All right, divide by 2. I wanted to say AM equals 1/2 AB, so let's divide the 2. And obviously, if I'm dividing by 2, that's going to be my division property. Okay, division property of equality. Division prop. Oops, I put a 6 here. That was really step 5. So division property of equality. And then for my sixth and final step, this one, I'm sorry guys, I'm going to have to kind of like curve this right here. Okay, my sixth step is, well, I want to say AM is equal to half AB and MB is equal to half of AB. Well, I can just substitute MB, right? I could just substitute MB back in for AM. So MB then also has to equal 1/2 of AB. And my reasoning for that one there is substitution, or it could be transitive. Okay, it could be transitive in that case as well, because I know AM equals MB and I know AM equals 1/2 AB. So substitution or transitive works there. All right, so let's just quickly discuss what is the difference here between midpoint theorem and definition of a midpoint. Well, the midpoint theorem says that each piece is half of the whole. Okay, that's how I remember it. Each piece is half of the whole. So it tells us that AM is equal to 1/2 AB, and that MB is 1/2 AB. Obviously, it changes for every one. This is just using the example we just have. Whereas the definition of a midpoint tells us that the two pieces are equal. Okay, the two pieces are equal. It divides it up into two equal pieces. So this tells us that AM is equal to MB. Okay, the lengths of each piece have to be equal. All right, let's take a look at the angle bisector theorem now. This is going to be very interesting and very similar. So if ray BX is the bisector of angle ABC, then the measure of angle ABX is equal to half the measure of angle ABC, and the measure of angle XBC is equal to half the measure of angle ABC. Oops, just dropped my pen a little bit there, sorry. All right, and so this proof is going to be very similar to the one we just did. These are my statements over here on the left, statements. These are my reasons over here on the right, reasons. So my first statement is just the given. Ray BX is the bisector. I'm just going to say bisects angle ABC. My reason for that, well, of course, it was given to me. All right, so my reason is just that it's given. And now this is going to go almost the same exact way as midpoint theorem went. It's just now we're dealing with angle instead of segments, an angle instead of a segment. So my next step, all right, well, I used definition of a midpoint as my second step to say that the two halves were equal. Let's do the same thing here. So let's say measure of angle ABX, right, there's 1/2, has to be equal to the measure of angle XBC. Okay, each half has to be equal to each other. That is definition of a bisector. Definition, I forgot an I in there, definition of angle bisector. All right, my next step is, well, if I add up each of those pieces, it gives me the whole. So my measure of angle ABX plus measure of angle XBC has to equal the measure of angle ABC. And last time we did it, that was segment addition. Here, it's just angle addition, right? Now we're dealing with an angle instead of a segment. All right, our fourth step, let's substitute in. I'm going to substitute measure of angle ABX. I know it's equal to measure of angle XBC, so I'm going to substitute measure of angle ABX in right here. So measure angle ABX. Sorry guys, I'm not sure why this isn't writing. ABX plus measure angle ABX has to equal measure angle ABC. And again, we were just substituting in ABX for XBC, so that reason is substitution. Okay, that's the same thing as 2 times the measure of angle ABX. Okay, so we don't even need to write a new step, right? That's just the same exact thing. We're not actually doing anything there. So now let's divide that over. Divide by 2, we get measure angle ABX equals 1/2 measure angle ABC. And that is our division property of equality. And finally, we'll substitute in measure of angle XBC for measure of angle ABX. So that is substitution. All right, and we have now proved exactly what we wanted to. So that was also substitution. Again, transitive would work for that one as well. All right, so the angle bisector theorem versus the definition of an angle bisector. Very similar here. The angle bisector theorem tells us that each piece is half of the whole. All right, each piece is half of the whole, whereas the definition of an angle bisector tells us that the 2 pieces have to be equal, must be equal. So really the same exact thing as the midpoint theorem versus the definition of a midpoint. However, this time it's with angles as opposed to segments. Hope this helped you guys out, and enjoy the rest of your day.